section 5.7, applications to differential equations. Here is a recall. Consider this first order differential equation, dx over dt is ax. To solve this differential equation, we may rewrite it in this way. We consider the derivative as a fraction, then we can multiply dt, and now we divide by x. Then we can reach at this one. Now we integrate both sides, left-hand side with respect to x, right side with respect to t. Then left-hand side becomes logarithm of absolute value of x, and right side at, and we have to put here an integration constant. Now then we can apply exponential function. Then absolute value of x is e to the that one. Now we eliminate the absolute sign by putting plus minus sign on the right side. Now it can be written in this way, and this term is a constant, and we are using C notation to get the solution. So let's try to solve this differential equation. Now if we use that formula, then x will become here c times e to the 5t. Here a is 5. Rather than using the formula, let's try to solve it step by step. Okay, a. Now from the equation we have now dx over x is the same as 5 dt. From that, there is a integration. It gives a logarithm of absolute value of x, and right side is 5t, and plus some constant. Now we apply exponential function, then x absolute value is same as e to the 5t plus k, which is, okay, that is k, capital K, which is same as e to the k constant times e to the 5t. Now from here, x itself is the same as now plus minus e to the k times e to the 5t. By using notation C, we can have here c times e to the 5t. That's the general solution. When we are using the initial value x0 equal 2, then okay, x0, that must be 2. From here we have that c e to the 0, which is 1, so there's c. So we decide c is 2. So the final answer is here x equal now 2 e to the 5t. Okay, that's the final answer. Now check if our solution satisfies both the differential equation and the initial condition. Okay, for that one, if we differentiate it, dx over dt, then there's constant, and then by using chain rule, we have e to the 5t, and then we have 5 here. Now that one is, we can write in this way, 5 times, and that is 2 e to the 5t. But that one is x, so we can write here, there's 5x. So it is satisfying the differential equation. And how about the initial condition, x at 0? That is, if we put 0, then that is 2 times e to the 5 times 0. So is e to the 0 is 1. So we have here 2. So the function satisfies the differential equation and the initial condition. So that's the solution. Okay. Now, dynamical system is defined in this way. A system of first order differential equations of x1 to xn and here along with the quotients aij. So x1 prime is linear combination of x1 to xn and also x2 derivative and up to xn derivative are written as a linear combination of the functions x1 to xn. Then this kind of system is called dynamical system. By using here metric, so we collect the quotients to form the metric. Then we can write the system in this way. X prime, of course x is collection of x1 to xn, and so that x prime is the collection of derivatives of each function, and a is the collection of the coefficients. So the system can be written in this metric form. The question is, how can we solve the system? Here we have an observation. Lambda v is an eigenpair of the metric A. That means AV is lambda v. Then, along with arbitrary constant, V, CV, e to the lambda t is a solution of the dynamical system. We can check it quite easily. X prime t is now derivative directly for that one. Then here by using chain rule, lambda will come out, so we reach at this one. Now a times x of t, then because AV is lambda v, that portion along with AV will be changed into lambda v, so that we can reach this term. They are the same, which means that with an arbitrary choice of C, this term is a solution of the dynamical system. Okay, so to find the solution of dynamical system, we may start with finding eigenvalues and eigenvectors. Okay, we have initial value problem, a dynamical system, and we'll try to solve the problem. Okay, first we have to find the eigenpairs, lambda I, vi, then we try to formulate the solution along with arbitrary coefficients. Okay, let's do that. So A is given over there, so that to find the eigenvalues and eigenvectors, we start with A minus lambda I, minus 4 minus lambda, and minus 2, 3, and 1 minus lambda. Right? And its determinant is the same as, okay, that is lambda plus 4 with negative minus 1 multiplied, and again the same here, lambda minus 1, and here plus 6. That is same as lambda squared plus 3 lambda minus 4 plus 6. So we solve this one with 2-1 separation and plus plus. So we have here lambda minus 1 and minus 2. There are two eigenvalues. Now for lambda minus 1, Okay, yes, lambda is minus 1. Then a minus lambda I is obtained by adding 1 along the diagonal. So that is minus 3 and minus 2 and 3 and 2. Now we have to solve this homogeneous system to find the corresponding eigenvector. So essentially these two are the same, and just the addition will make one row 0. So here the corresponding eigenvector, let's try to use the notation V1. Okay, that is a lambda 1. Okay, we'll use the notation V1 for lambda 1. A corresponding eigenvector V1 is now change the position and try to make one of them negative. So it is 2, 3, and let's try to get that way. So it is a corresponding eigenvector. How about the other one? Lambda 2 is minus 2. Then a minus lambda I is obtained by adding 2 along the diagonal. So it is minus 2, and 3 and 3. Okay. So again, we have to solve this problem. And the solution, one of them, will be an eigenvector for lambda is minus 2. Now again, okay, that is essentially the same, so that anyway, 1 and 1. And let's try to choose minus for that one. Okay. So we reach an eigenvector. Now, so that the solution can be formulated in this way. X is C1 along with C1. Now, this vector V1 is 2n minus 3 and e to the lambda t minus t plus a constant, arbitrary constant, and the second eigenvector 1n minus 1, and its corresponding eigenvalue is minus 2. So that e to the minus 2t. Now, we have to decide here C1 and C2. How? By using the initial condition. Once t is 0, then we have here now C1, that is 1, so that 2n minus 3, and plus C2, that is 1n minus 1, and that is 1. And that must be same as the given data minus 2 and 4. We can decide the C1, C2 quite easily. This is a linear combination of two vectors equals that one. So that now to find the C1 and C2, you may start with the corresponding augmented matrix, and 2 minus 3 and 1 and minus 1, and first column, second column, and right side minus 2 and 4. If you apply elementary row operations, then this first portion will become identity, and apparently that will become here minus 2 and 2. Okay, so C1 is minus 2, C2 is 2. So we end with this solution. And if you try to form a vector, and first one and second one, that is basically the changing the x values and xy coordinates, and this second one will make y values. So that is exactly now this one. So it's minus 4 e to the minus t okay, like that. And 2 and e to the minus 2t, that is x value and y value. Along with this x value, y value, and the curve direction is printed, then we have that one. For this problem, initial point is now minus 2 and 4. So x is minus 2 and y is 4. So that that must be around here. Okay, so start with this one. Then, so that the solution curve will make in this way. Right? Here, x is minus 2 and y is 4. So from here, now changing over there. If your initial value is around there, then your solution curve, that one will make such kind of a trajectory. Now that one, the vector, this one is 2 and minus 3. In fact, that one is here the v1, and which is corresponding to the eigenvalue lambda 1 is minus 1. Now this vector is v2, and that is with lambda 2, that is minus 2. Now along that direction, and the curve is shrinking very fast because now that is e to the minus 2t as t increases. Now this one and that one simultaneously approaching 0, and now along that direction, in 1 and minus 1 direction, this value is more rapidly shrinking. So along the direction, as t increases, x values and y values simultaneously are approaching 0, and we have such a profile. This is rapidly, and of course along this direction is shrinking, but along that direction is more rapidly shrinking. So that's the observation through computer graphics. Okay, we'll deal with other more details in the second part. Thank you.